Today in this video we will see one numerical on strength of material subject, simple stress and strain on member subjected to axial forces. Numerical is a copper wire of length 600 mm is subjected to an axial pull of 10 kN. Find the minimum diameter so that the stress is not to exceed 75 MPa. Also calculate the elongation if E is equal to Young's modulus is equal to 100 GPa. So given data is copper wire of length 600 mm, is subjected to an axial pull of 10 kN. Axial load 10 kN. Find the minimum diameter so that the stress not exceed 75 MPa. Stress not exceed 75 MPa. MPa, that means Newton per mm square. Also calculate the elongation if E is equal to 100 GPa. E is equal to 100 GPa. 100 GPa is equal to 100 into 10 raised to 3 MPa. A copper wire of length 600 mm, copper wire of length 600 mm is subjected to an axial pull of 10 kN. Find the minimum diameter so that the stress is not exceed 75 MPa. To find minimum diameter of copper wire so that the stress is not exceed 75 MPa. Also calculate the elongation. Second, elongation. So solution to this problem is first, minimum diameter of copper wire. So by using formula, stress is equal to load upon area. Stress is equal to load upon area. Stress is not exceed 75 MPa. So stress we have taken 75 is equal to load is 10 kilonewton. Convert it into Newton. 10 into 10 raised to 3 Newton divided by area. So area is equal to 10 into 10 raised to 3 divided by 75. Area is equal to 10 into 10 raised to 3. 10 into 10 raised to 3 divided by 75. 133.34. 133.34. Area is in mm square. So after this we have to calculate minimum diameter of copper wire. So we have taken area is equal to pi by 4 into d square is equal to 133.34. So d square is equal to 133.34 multiplied by 4 by pi. Value comes 133.34 multiplied by 4 divided by pi. 169.76, that is d square value, diameter square value 169.765, and square root of it is 13.02. So our minimum diameter of copper wire comes 13.02 mm. Now next we have to calculate elongation of copper wire. So for elongation of copper wire, I have take Young's modulus formula. Young's modulus is stress upon strain, stress is load upon area, and strain is change in length upon original length. So by that we have get formula for elongation. Delta L is equal to E is equal to P by A into L by delta L. So delta L we get P by PL by AE. Put values in this formula. Our P load is 10 into 10 raised to 3. L is length of that copper wire 600 mm divided by our A is area 133.34 multiplied by E. E is our Young's modulus of elasticity, stress upon strain 100 into 10 raised to 3. So for our elongation value is 10 into 10 raised to 3 multiplied by 600 divided by 133.34 multiplied by 100 into 10 raised to 3, 0.45 mm. It's elongation. So for that copper wire of 600 mm length with axial load of 10 kilonewton and stress not exceed 75 MPa, stress not exceed 75 Newton per mm square, our diameter for that copper wire is 13.02 mm and elongation is 0.45 mm. By the formula stress is equal to load upon area, we have calculate diameter for that copper wire, and using formula Young's modulus we have calculate elongation for that copper wire. Okay, thank you very much.